Okay, this lesson is going to be about radians and how they relate to degrees. First, I'm going to define what a radian is, then I'll talk about the relationship between degrees and radians, then I'll do some examples of converting radians to degrees, and then converting degrees to radians, and then you're going to try a few practice problems. So what is a radian? And you should be familiar with this term from your Algebra 2 class, but it's actually a measure of an angle that, when drawn as a central angle, subtends an arc whose length equals the length of the radius of the circle, which seems like a crazy mumble jumble. But if you look at this picture here, you have the radius here, okay? The length of a radian is the length of a radius if you were to wrap it around the circle. Okay, it's another way of expressing the measure of an angle, and that's why we can compare degrees to radians, because they both measure angles. So what's the relationship between a radian and a degree? So we know 180 degrees is a semicircle, okay? Exactly 3.14159 ... radians go along a semicircle, but we know that 3.14159, etc. is the same as pi. So that means there's a pi worth of radians around one semicircle. So we can use this idea that pi radians equals 180 degrees to make conversions between these two. And this is written really small, but 1 radian equals 180 over pi degrees, and 1 degree is equivalent to pi over 180 radians. So let's do a couple examples. So we're going to convert these radians to degrees. We want to convert pi over 6 to degrees. And to do this, what we do is we multiply by 180, because before we read that 1 degree equals pi over 180 radians, and vice versa, 1 radian equals 180 over pi degrees. So we're going off the fact that 1 radian equals 180 over pi degrees. So you're going to multiply the radians by 180 over pi. So we have pi over 6 times 180 over pi. Okay, we did the first step. We want to notice when we multiply across, okay, so we're left with pi times 180 over 6 times pi. Okay, you should notice that since we have a pi over pi and we're multiplying, these should cancel. So I'm left with 180 over 6. Okay, so those will cancel. Now you need to simplify the fraction. 180 over 6, if we were to divide those out, that would be 30. And because we went from radians to degrees, this would be 30 degrees, and that should be your final answer. Alrighty, let's go to degrees to radians. Alright, so we're going to convert 50 degrees to radians. To do this, you multiply by pi over 180, because 1 degree is equal to pi over 180 radians. It gets a little confusing. So the first thing we're going to do is multiply 50 times pi over 180. Okay, and we know that 50 is the same as 50 over 1, so you can rewrite it like that if you want to see the full fraction. So we're left with 50 pi over 180 times 1, which is just 180. What you're basically going to do is you're going to ignore the pi and simplify the fraction. You're basically leaving it in terms of pi. So we're just going to ignore the pi for right now. We want to divide these two right here. And 50 over 180 would be reduced to 5 over 18. And you just tack that pi on in the numerator. So 50 degrees is the same as 5 pi over 18 radians. Okay. Basically, what's happening is you're either multiplying by pi over 180 or 180 over pi. And sometimes it's a little confusing to memorize this. Instead, the strategy I like to use is I know that when I want to get degrees, okay, I need those pi's to cancel. That means I need a pi in the numerator, I need a pi in the denominator. Otherwise, when I want radians, okay, I know the pi needs to be in the numerator, so I know to multiply by pi over 180. And that's my trick for memorizing. For radians, the pi needs to be in the numerator. To get degrees, the pi's need to cancel, so I would have to have the pi in the denominator when I multiply like it is here. Okay, so now I'm going to ask that you pause your screen in order to solve for these guys on this page. So you're going to pause, you're going to convert 1 and 2 to degrees and convert 3 and 4 to radians. And I will just need a minute or so to do the same. So the first one should be 100. The next one should be 60. This should be 11 pi over 6. And this last one should be 2 pi over 9. And there you have it, converting degrees to radians and radians to degrees.